Welcome to Academic Gurus Tutoring Thursday, where we answer all of your high school, college, and university questions. If you would like your question to be featured on next week's Tutoring Thursday, please submit your questions to questions@academicgurusinc.com. Don't forget to subscribe so you can stay current with all of our new videos. In today's session, I'll be solving two questions that were posed by Ashi98. The first question is a sequence question, and the second question is a graphing question. We'll start with the sequence question, and the question reads, which of the following functions best describes a sequence where the first four terms are 7, 4, 1, and -2? And we've been given various options, and we're to determine which one is the correct one. As always, I'll be breaking this question down into steps, and the first step is to make sure that you understand what the question is asking. So in this case, 7, 4, 1, and -2 is a sequence of four terms where n determines the position within the sequence. Therefore, n equals 1 is the first term, in this case 7. N equals 2 is the second term, in this case 4. N equals 3 is the third term, which equals 1. And n equals 4 is the fourth term, which is equal to -2. So again, n is simply a representation of where within a sequence a particular term is located. So now that we understand what the sequence of numbers means, let's move on to understand what f of 1 equals 7 means. F of 1 equals 7 simply means that for n equals 1, that is the first term, the value is 7. The second part has f of n plus 1, and we can simply think of this as the term immediately following the term n. Therefore, as an example, if n equals 1 and f of 1 we've already determined is equal to 7, then n plus 1 is simply 1 plus 1, which is equal to 2. That is the second term. And we also know that f of 2 is equal to 4. So again, that's 4 immediately follows 7. This example is true regardless of which term you decide to work with. If n were to equal 3, you would follow the same sequence. It would be f of 4, which is equal to -2. Next, we're dealing with f of n plus or minus some constant. We can call that a. A simply represents 3 or -3, -4, or +4. In other words, for any term within the sequence, add the constant a. Now, if we put this equation together, we can think of this as f of n plus 1 is equal to f of n plus a. That is, to determine the value of any term within a sequence, add the constant a to the value of the term immediately before it. And that is what we see up here. Next, we're given a restriction, which says that for n which is greater or equal than 1, this simply means that for the preceding function, this function holds true for any position within a sequence that is either the first term or any term thereafter. Now that we understand the different parts of the question, we can go on to analyze the question, which is step 2. So let's revisit what we already know to be true. For n equals 1, f of n equals f of 1, which is equal to 7. The first term is 7. Since we've decided that n is equal to 1, we know that f of n plus 1 is equal to f of 2, which is equal to 4. Now, after putting the two parts together, we have f of n plus 1 equals f of n plus some constant a, which we're trying to determine, given the restriction that n is greater than or equal to 1. That is, f of 2 is equal to f of 1 plus a, which in turn means 4 is equal to 7 plus a. Now all we need to do is solve for a. In a previous session, we discussed how to solve for a constant. So we'll apply the same method here by adding -7 to both sides of the equation in order to solve for a, and the equation reduces to a is equal to -3. Therefore, f of 1 is equal to 7, and f of n plus 1 is equal to f of n minus 3, with the restriction for n greater than or equal to 1. If we go back to our original equation, we can see that B is correct. Again, all that it's saying is that for the given sequence 7, 4, 1, and -2, you can determine the next term by subtracting 3 from the previous term. Now we can move on to the second question. The question reads, the table below represents the atmospheric temperature at a location as a function of the altitude. The average rate of change of the function between x equals 15 to x equals 25 is some degrees Celsius per 1,000 feet and represents the rate of change of temperature per 1,000 feet. In ASHE 98, I determined that it is -2. So we've been given a chart here of the altitude in 1,000 feet versus the temperature in degrees Celsius. And the best way to approach this question is to actually plot a graph. Here we have a graph, and given that altitude is an independent variable, we will label the x-axis altitude in 1,000 feet. And given that temperature is the dependent variable, we've labeled the y-axis temperature. That is, the temperature depends on the altitude. Now the question is asking us to determine the average rate of change. And the rate of change is simply the slope of the graph. We can see we have a linear line here. And to determine the slope of the graph, we look at the difference in rise versus the difference in run. If we were to select the first 2 points and locate them on the graph, then the rise, or the change in temperature, is simply -6 minus 4. That is, we're measuring the difference in temperature between these 2 points. The run, on the other hand, is the difference in altitude between these 2 points. In other words, we take 20 minus 15, which is equal to 5. So the rise is equal to -10 and the run is equal to 5. We've already determined that in order to calculate the rate of change, we have to divide the rise by the run. So therefore, we take -10 divided by 5, which is equal to -2. So there you are, ASHE 98. It looks like you're correct, and I hope you found this helpful. Thank you for tuning into our Tutoring Thursday channel. If you enjoyed watching this video and found it helpful, please give us a thumbs up, comment, and subscribe. We would love to hear from you. Until next week's Tutoring Thursday, happy studying.